Hola, estudiantes. Estoy en Costa Rica hoy. I hope you're doing okay. And I know you saw a video that showed you how to do the graphing method, and I just wanted to do a couple examples of your book. So what we're doing is we're using graphs to solve linear systems. You'll have two equations that have an x and a y, and you have to find all the ordered pairs that make both equations true. I'm going to hop right in because I'm my own cameraman. Okay, I hopped right in. This is take 4, so wish me luck. I gotta get this one right. Okay, so we're looking for two equations that have x and y in it. We're going to graph the two equations and see where they cross. That's really what we want to do. We want to see a point that lies on both of these lines at the same time, because that point is going to solve both of these equations also. And so let's see. We've got y equals x. In order to graph that, let's make a t-chart. X and y. And you can put anything you want in for x that gives you an integer for an answer. Let's choose small, easy numbers, like let's start with 0. If I put a 0 where the x is, look at what y is. It's also 0. Pop a dot on 0, 0. Okay, we need 2 points to make a line, so let's choose, I don't know, let's choose 2 this time. And if I put a 2 where the x is, then y equals 2. And I'm going to pop a dot at 2, 2. Now, in the past, I haven't cared if your lines were a little wobbly, but in this section, you need your lines to be really, really straight, because we need to see where they cross. So use a ruler or a straight edge unless you're really, really good at making straight lines. So there's my first line. Now for my second line, I'm going to do the same thing. I'm going to choose some values for x and find out what y would be. I'm going to choose easy numbers again, like 0. If I put a 0 where the x is, 6 minus 0, 6. Okay, plot that. 0, 6. Pop a dot. One more point. Let's do 2 this time. How about a 2? If x is 2, y would be 4. Okay. Over 2, up 4, pop a dot. And now we need to make that line really straight, like I said before, really straight. Ooh, it's already curvy. That's okay. It's going to be okay because I can see where they cross. I can see that they cross right here. That means 3, 3 is the solution. Coordinates for that point are 3, 3. That means that this point lies on both lines, and that if I put a 3 in for my x and a 3 in for my y, oopsie, 3 in for my x and a 3 in for my y, it works in both equations. Awesome. Okay, next. All right. In this next system, I've got some kind of nasty numbers to work with. I always feel like it's easier if I put them in slope-intercept form, so that's what I'm going to do. I'm going to put this in slope-intercept form. And so I'm going to get it in this form, y equals mx plus b, slope, y-intercept. So I need to move my x's over there. Move my x's over here. Negative 9, y equals negative 3x. And divide by negative 9 to get y alone. And y equals 3 over 9 is 1/3. And negative over negatives, positive, dance moves, and x. Oh, you know what, that's going to be really easy to use a t-chart with. I'm going to use a t-chart. Okay, t-chart. Put a 0 in for x. A third times 0, 0. I don't want to work with fractions because it's too hard to graph a fraction and have somebody else know exactly where it is. But if I make x 3, I will be able to get rid of that fraction, and y will be 1. So let's plot these 2 points, 0, 0, and 3, 1. There is my first line. Muy bueno. I know I'm going kind of fast. I have to, so I don't run out of space on my iPad, and you guys should be ready to go this fast. I'm going to rearrange this pup too. I'm going to make him in slope-intercept form too. Put the x first because that's the way it is in slope-intercept form. And then put the -3. Remember there's an invisible one there. Now to get y alone, divide by 3 everywhere. Y equals, I can rewrite this as 1/3 times x, and then it's easier to understand. -1. Okay. I can either make a t-chart or I can just use slope-intercept form for this. You know what? This is my y-intercept, so that's where it crosses the y-axis, which means it's right here, -1. And my slope is 1/3. 1/3 is my slope, so 1/3 is my rise over run. Rise 1, run 3. Rise 1, run 3, and pop a dot, and then draw a very straight line, and, oh, well those lines look parallel. You know what? They are. They're parallel, they're never going to touch. They're going to go on and on and on. This way, on and on and on, without ever touching. There will be no solution to this problem. So if you find parallel lines, you write no solution, wah, wah, wah. Next. Okay, here's another weird one. Because most of your lines that you're going to do are going to cross at one point, and you'll have an answer, you'll have a set of coordinates, like 5, 2, or 1, -3. But some of them are going to be like that, where there's no solution, because they're parallel. And some of them are going to be like this one. I'm just going to graph this first line using slope-intercept. Here's the y-intercept, 1 on the y-axis. My slope is 1/2. Rise 1, run 2. Rise 1, run 2. Right there, draw my line, very, very straight. Please draw it straighter than I just did. And then you graph this line. You're going to find out that the second line lies exactly on top of the first line. So what you actually found out is these two equations are for the same line, just it's said in a different way, but they're the same line. That means that every point on the first line is the same as every point on the second line, and a line has infinite amount of points, and so the answer is infinite answers or infinite solutions because they're the same line, so of course all of their points are the same. And good luck, buena suerte, see you in a week. Turn it off.